math agony, Aunt. My lower ability maths class has recently been looking at calculations involving the circumference and diameter, but some don't understand the relationship. Can you suggest how I could introduce the concept of pi in an inspirational way? Thanks, Peter Barsby.
It might surprise you, but the answer could lie in shopping.
When introducing the idea of pi, it's a good idea to start off with something familiar. Now, shopping is about as familiar as you can get.
In this shop, there are lots of things to help with teaching of pi, including a helpful store manager.
Oh,
got those
thanks.
bits for you.
That's great. Brilliant. Okay, right, if you could hold that for me.
Okay.
And I'll take that. Now, what I'm going to do is I'm going to wrap the till roll around the container. Can we make a little mark there?
Yeah.
Then I take that piece of till roll and I just fold it along my mark, but make sure that I've got it absolutely square. And then, yeah, I'll cut that bit there.
I'll cut it for you.
Yeah, that's great, thanks. There we go, and you cut that there. If you take this, and this is the bit that is the wow moment for everybody, if you take that, that's the diameter, so the widest part of the circle, going through the centre. If you take that and you fold it in about 3, not exactly 3, and you see that it fits about 3 times. Actually, it's pi, it's 3.14, blah, 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 the number goes on.
Does that work on any size?
Yeah.
Tin?
Yeah. If you've got another 10, we can go and have a look at the bigger tin.
I've got a big one over here, actually.
Oh, right, okay, let's go and try that one. Yeah, that'd be great. All right, oh, yeah, that's great. How about if I hold the tin this time and you do the...
Okay.
This is a very visual way of introducing pi, and anyone can do it.
So, about 3 times.
Slightly over.
It's clever, isn't it?
It is. That's good,
great.
that. Excellent.
That's great, thank you. We're off to Viner's School in Hillingdon to see Jackie Edwards using this approach with her foundation level pupils.
She starts the lesson by making sure the pupils know the names associated with the circle.
First of all, can you tell me any words that you would associate with the circle? Any word that you can think of? Any words? For example, I can think of one that begins with D.
Diameter.
Good, well done. Right, now that's one word we've got. It's a Year 8 group and it's a foundation group, and their ability level would range between national level curriculum 2, and some of them actually have reached level 4. What about the letter R?
Rotation.
Rotation is to do with the circle, but it's not the word I'm after, right? The word radius. Have we heard of radius before? Right. Now, there are other words that obviously we're going to have to learn this morning, okay? Now, then I've got...
Jackie covers other parts of the circle like the circumference, centre and segment. Using the interactive whiteboard, she gets the children to come up to the front and connect the words with the graphics.
Any word you like. We've had the interactive whiteboards since September, and we use them a lot in activities like that at the beginning of lessons. They're very used to doing that now. It's becoming very much interactive in all parts of the lessons, where they will come up and use the whiteboard and even draw on the whiteboard. What I'd like you to do now, if you look at what you've got on your table, we've got a set of tins, you've got some labels. We're going to see if we can discover something about 2 of the words. The 2 words we're concerned with will be the diameter and the circumference. Now we are going to investigate something special about those 2. Now,
Jackie carefully explains how to wrap the till roll around the can and cut it to the exact circumference.
now then, I want you to experiment with this piece of paper, right, and see if you can see any relationship between the distance around the outside, the circumference, and the distance across the middle, the diameter. Okay, so do you want to get started?
The pupils try this activity with 3 different size cans: small, medium and large. This physical activity of wrapping, cutting and folding is a more practical and involving way of beginning to investigate pie. It looks as though Charlie has gone beyond what Jackie has asked him to do. He's decided to cut the label into 3 equal pieces.
Now, I did ask you to be looking at the relationship between the label, the circumference, and the tin. Now, I could see as I was going round, Charlie has actually found something quite interesting. Charlie, can you explain what you've done?
We marked out the circumference of the piece of paper on the tin, and it's 3 of these.
Charlie's played right into my hands there. He's sorted out something, especially with the number 3. I mean, that was good on his behalf to actually have thought that out, because that was no prompt from me at all. He had an absolutely magic moment there, yes. Now, you've worked on the circumference. We've now got to consider the diameter. Now, to find out the diameter, to be as accurate as we can, we could, if I take yours, Alfie, we could try and do it with a ruler, just going across, but that's not going to be all that accurate.
Jackie wants to improve their measuring skills, so she introduces this method using set squares and a ruler. Having measured the circumference and the diameter of the 3 different cans, they enter their results into a table. D is for diameter and C is for circumference. R stands for result, which hopefully will equate to the value of pi.
Right, that's fine. From a table, we're looking for pattern. Is there a pattern in our results? Priya?
And the circumference is bigger.
How much bigger is the circumference?
The pupils aren't seeing the relationship immediately, so Jackie takes a slightly different tact.
Suppose I had these figures here. Now, there's a relationship between those numbers. There's a pattern there for sure. Nikita?
You've got to times 3 each time.
You've got to multiply each time by 3, that's right. Right, so there is a rule. That is a pattern, right, that Nikita has found. Now then, can you look at our numbers, the ones we've discovered this morning, and can you see a link between those numbers? I'll give you a clue. If you remember what Charlie did before, right, Charlie cut his circumference up, and what happened? What happened to his circumference when he put it across the diameter? How many diameters did he get out of his circumference? Callum?
3.
3.
Jackie starts to build on this first step in understanding the relationship between the diameter and the circumference.
What I'd like you to do, on your calculator, you're going to put in the circumference first, right? So in the first one you'll put in 16.5 and you'll divide by 5 and then write your answer in the results column this time.
By doing these calculations, they find out for themselves that the diameter goes into the circumference 3 and a bit times.
And then you divide it by 7.5. Divide it by 3.44. No, the remainder of them. Oh, we just put an R because it's remainder, isn't it? You don't count the remainder. 3.3 divided by 10 equals 33, the remainder 1.
Actually, their results look pretty good.
This works for every single circle. You can take the diameter and it will wrap round your circle always. It's 3.142 is what we usually use, but it doesn't stop there.
It certainly doesn't stop there.
Pi is an irrational number. It goes on forever. Brilliant mathematicians have worked pi out to billions of places. 3.1415926538979323846264338327.
If you went up to London, say, can you think of any circles that would spring to mind? Chloe?
The Millennium Eye.
There's the London Eye. The circumference for the London Eye is 424 metres in circumference.
As I did with the shopping, Jackie looked for other practical and everyday examples to help the pupils understand pi. They made real progress in this lesson. They weren't defeated by pi, but they were defeated by one particular word.
I learnt diameter. What's that word? I learned how to measure diameter and what's that word again?
So I learned about the diameter and the
circumference. Yeah.
Was it the
I learned how to do the circumference. Yeah, the circumference. I think the result was 3 point. Was it Chris?
When I divided the circumference by the diameter, I got 3.14.
3.14.
And what was that called?
Pi.
I think the secret to making maths interesting is to use everyday objects that children can relate to. Jackie in her lesson introduced the London Eye. You could perhaps use the Ferris wheel from the local fair and do calculations on the radius and the circumference. There are lots of circular objects in the environment. Here's a couple for a start. They could measure the circumference of different trees and work out an estimate for the age of the tree. Jackie also gave them homework on the diameter and circumference of the Earth, which might make them realise how enormous our world really is. Anyway, Peter, thanks very much for your letter. It certainly made me think. And I hope it's given you lots of ideas that you can use in your maths classroom.